Hello friends, welcome to Hydrostatic.com. Today we meet to discuss hydrostatic forces on surfaces, and we shall discuss basically fluids which are static or at rest. And this means in those fluids there will be no relative motion between adjacent fluid layers. And according to Newton's law of viscosity, velocity gradient, which is the change of velocity between adjacent fluid layers divided by the distance between the layers, will equal to 0. The shear stress, which is equal to nu del u del y, will equal to 0 according to Newton's law of viscosity, meaning that is shear stress, which is directly proportional to nu du dy, will equal to 0. Meaning that the only forces that are going to act on the fluid particles are going to be the pressure force, which will be normal to the surface, and the force due to gravity or self-weight of the fluid particles. So when this force acts on the surfaces, there is what we call total pressure, or the resultant force exerted by these pressure forces on the surface. It can be defined therefore as the force exerted by the fluid on the plane or curved surface when it comes in contact with the surface. This force is always acting normal to the surface, whether plane or curved. And therefore the center of pressure is the point of application of this resultant force on the submerged surface, or is the point on the submerged surface where the resultant hydrostatic pressure force acts. The following cases are considered of submerged surfaces, and therefore total pressure and center of pressure will be required to be calculated or determined. And one is vertical plane surface, horizontal plane surface, inclined plane surface, and curved plane surface. Thank you so much.